and not by the girl. And this means that the boy is more interested in things and the girl more in faces, social context, dolls, etc. And we have studied this process of differentiation during development of the brain by collecting brains from donors. And you can see here somebody who is thinking over the question whether she leaves her brain behind in the institute, which is our queen. We established a known brain bank in order to have material for investigation. It's post-mortem material, and since the start of the brain bank we did 4,000 autopsies, and we have sent over brain material to 500 research groups in 25 countries. So the Dutch brain is spread over for research purposes all over the world. And what we found in the 80s was that there are 6 differences in the structure of the brain. And you can see here the first one, which we described in a region that is called the hypothalamus. It's a region important for sexual behavior, and we call this structure the sexual dimorphic nucleus. And it's larger in males than it is in females, has more cells in males than it has in females. And this was those days not accepted by the feministic movement. And one of the leaders of the feministic movement in the Netherlands said, if I would accept that there are sex differences in such fundamental properties as the anatomy of the brain, I can stop talking as a feminist. And since then, we never heard of her. Since then, there are hundreds, no, thousands of publications about sex differences in the human brain, and it's now a well-established fact. And we are worrying about compounds that might interact with the sex hormones and the developing brain. And one of the examples are phthalates, as mentioned here. Those are weakeners of plastics, and you find them everywhere. And when children have a high level of phthalates in their urine, they don't show the sex difference in playing behavior anymore. And what that means for the later sexual development in terms of gender identities or the feeling to be male or female or sexual orientation, we don't know yet. That has to be studied. What is important in programming of the brain during development is that it is an irreversible process. It's now or never. It's changed for the rest of our lives. And you can see that from this little girl walking here. And she was born as a boy. But the foreskin of the penis was had an opening that was too small, and therefore urination was difficult, and this gives kidney damage in the long term, so he had to be operated, and the operation is a small one. The foreskin of the penis has to be removed. But in the operating theater in Canada, they made a mistake, and they did not burn small bleeding blood vessel, but they burned away the whole penis of the child. And because those days it was thought that it was the social environment that was pushing the child into the direction of a boy or a girl, it was decided to make a girl out of this little boy. She got dresses, or he got dresses, was psychologically guided by John Money in the United States, got toys for girls in which he was not interested, and in puberty she got sex hormones from a female kind, so estrogens. And when I said some 18 years ago in the United States, this is the only example that I know of that it was successfully possible to change gender identity, so the feeling to be male or female after birth, because of the publication of John Money. Somebody stood up, that was Milton Diamond, a sexologist in the United States, and he said the whole story of John Money, that this was a success, is nonsense, because in adulthood this person changed back into a man. And it means you can do anything you can imagine. You can remove the penis, you can dress the child up with dresses, you can give psychological guidance and girls' toys, and you can give estrogens in puberty, but you don't change gender identity, because that has been programmed before birth in the womb. It's structurally defined in the brain during early development. Well, this is Miss Canada, and she was also born as a boy, but from the age of 5 she knew that she was born in the wrong body. And this is called transsexualism. And you can see that the body has been changed quite successfully. So the theory about transsexuality was that since our sex organs are developing in the female or male direction in the first 2 months of pregnancy, and the brain is sexually differentiating in the second half of pregnancy, those two processes can be influenced in a differential way. You can influence one without the other. And if that would be true, then you would expect female structures in male brains and the other way around in transsexuals. And that's what we found. You can see here a red structure. It's called the bed nucleus of the stria terminalis. It's not important. But what is important is that it's a crucial structure for sexual behavior. And if you look to that structure under the microscope, you can see here it is in a heterosexual male, and here it is in a heterosexual female. So the structure is smaller and has less of those black spots, which are contacts of fibers coming from other brain areas that are also important for sexual behavior. This is a homosexual man. There's no difference between homosexual and heterosexual in this brain area. There is in other brain areas. And this is a genetic male, but it's a male that is transsexual, from male to female. And it has a size of a female bed nucleus of the stria terminalis. And when we counted the number of cells in this area, it's 35,000 for heterosexual and homosexual males. It's half the number for females, and it is for genetic males that are transsexuals, the female number of cells. And you can see here one female to male transsexual. There's a high number of cells. So this is a reversal in the brain, which is in agreement with how those people judge their own gender identity. They feel the way the brain is built. And this gives, of course, the problem of their birth certificate, the passport, that should be adapted. What's also decided for us in the womb is our sexual orientation. And you can see here the famous same-sex marriage that was first taking place in Amsterdam. There's progress. You can see here in Taiwan, two girls marrying together in a Buddhistic environment. And you can also see here the text which tells us that if two men have a homosexual contact, they both should be killed. And I remember that it was once read in text like that in a mosque in the Netherlands, and then it was some 8 years ago or so, the Prime Minister those days came on television, Balka, and then he said that he would try to close the mosque and forbid the book. And then I asked at home, let's see how long it takes until somebody tells him that in the Bible you find the same text, Leviticus. And it took 5 days, and then he came on television again, and he said that the dialogue should continue between the different groups in society. Well, we found the first difference between males that were heterosexual and homosexual in the brain, and since then there were many structural and also functional differences described. I will just show you one, and this is a study in Stockholm by Ivanka Savic, and she put people in a functional scan without a task, so they just were resting in a scan. And then you can calculate whether a brain structure has a functional relationship to another brain structure, because they should go up and down at the same moment in activity. And if you do that for the left amygdala, like here, then in heterosexual males there are no other brain areas in which this structure is connected in rest. In heterosexual women you see several brain structures connected. In homosexual males it's the female pattern, and in homosexual women it's the male pattern. So this is a reversal, but there are also differences that are not reversals in relation to sexual orientation. Well, for sexual orientation we also know that it's a permanent change in brain structure and thus in behavior, because the last 100 years people have tried anything you can imagine in order to change homosexual men into heterosexual men. Female hormones were given, male hormones, people were castrated, transplantations were done, psychoanalysis was given. There was a compound injected, apomorphine, which makes you really sick. You start to vomit. And this was combined with homoerotic pictures, with the idea then you make another decision in life. But the only effect described was that when the therapist came into the room, the man started to vomit, but he didn't change his sexual orientation. There were brain operations done, electroshocks given, epileptic seizures induced, depth electrode plate, and prison. Still in many countries homosexual people are put into prison, and nothing has changed sexual orientation because it's programmed in the brain in early development. If we look into the evolution of the brain and we compare our brain, the human brain here, to the brain of the big monkeys, this is an orangutan, you can see the red hair over here, then the structure of the brain is macroscopically identical, but also under the microscope. You can see here the cortex, the small brain, cerebellum in both, the brainstem and the spinal cord. The only difference there is that the cortex in those orangutans is much smaller than in the human brain. And this is what happened during evolution. There were components added to the cortex of the human brain. And this went in a very quick time range. Well, if we realize this, then it's also logical that if you look in the society of big monkeys, that there are very big similarities between how we behave in societies. Every society needs rules, and the important rules to make society working are the moral rules. And Frans de Waal, I can advise you to read his last book, The Bonobo and the Atheist, is describing that all the building stones of moral rules are present in monkey society. So there's altruism, there's empathy. The monkeys don't accept a different payment for the same task. They can become very angry when you do it in an experiment. There's an incest taboo. There's gratitude, friendship, there is shame at breaking rules, and there's fear for punishment. So the moral rules are not given to us by religion. They are millions of years old, and they are set in our genes. They are set in a genetic way, in such a way that we can develop it in our society. There are many things settled by genetic background. There are also many things settled in early development, but it's not only genetics. And you can see that from those scans that are made from 2 children, one child 3 scans, another child also 3 scans at the moment of birth, shortly after birth. And this is an identical twin, but their brains are different, and you can see that between P and the L here there are 1, 2, 3 gyri, and here between the P and the L there are 1, 2, 3, 4 gyri. And that means that although those children have an identical genetic background, their brains are different at the moment of birth. And that's what the parents also tell you. They look very much alike, but they behave in a different way. They have a different character. They have a different brain. And this is because the brain is so complex that it cannot be developing on the basis of genetic information only. And the main developmental process is that locally the best connections are competing for survival, and the connections that are settling at the right moment and strong enough, they remain, and those connections that are too early or too late, they disappear, and with those connections also the cells disappear, and we make 5 times more cells than ultimately remain in our brain. It's a huge competition for the best contacts, which we call neuronal Darwinism. And this is not genetically determined. It's a local process by which all the brains become different. So we are all unique. It's not unique to be unique. Everybody is unique. During development, during the process of brain development, chemicals can influence the brain in a permanent way. What is also important is that the child gets enough food. So when there's not enough food in the environment, or when the placenta is not functioning well, the brain of the child has got problems in its development, and you will see more psychiatry later. There are also chemicals that influence brain development because the mother is smoking during pregnancy, or drinking alcohol, using drugs, medicines that are given by doctors. And what is important, we realize only recently, are chemicals from the environment. So there are many chemicals that are present in the environment, passing the placenta and influencing brain development of the child. And a recent example is that in areas where there is pollution caused by cars and factories, like in the big cities, for instance, there's an enhanced risk for autism, because those compounds are passing the placenta, influencing brain development, and also influencing brain development the early years after birth. Then the child is born and should develop in a safe and warm and stimulating environment in order to develop its brain according to its potencies. And when a child is neglected, that does not occur. And you can see here a child's brain 3 years old of a child that was neglected compared to a normal brain. And you can see it's smaller, the ventricles here are bigger, and this protracted development is also a permanent problem. So this child will never develop its brain fully because the first years were not stimulating enough. The most extreme form of neglect has been performed by Frederick II in the late Middle Ages. He was interested in the fact that all people have different languages, and he wanted to search for the language of God, the original language. So he has forbidden mothers to talk to their child, and he did that in some 20 mothers. And those children did not start to speak the language of God, they just died, because this is an extreme form of neglect. About the language of God, so when the child is growing up in a certain environment, we should know that we all have a certain amount of spiritual feelings. The idea there must be more than we can measure or see. But some people have more spiritual feelings than others, and that depends on the genetic background of the child. And the first one who has shown that is Dean Hammer, who showed a little bit of variation in a gene that is important for for chemical messengers to send one message, a message from one cell to another cell. And this gene is called vesicular monoamine transporter number 2. You can forget that. But it's depending 50% of our spirituality, just because we all have different sequences in our DNA. And if you are growing up into a religious environment, spirituality is filled in with that religion. And you can see here in China a child that is bending, praying for Kuan Yin, the female goddess in China. Parents are happy with that, and a peasant is encouraging the boy. And if you have very strong spiritual feelings, you do that for the rest of your life. And if you have little spiritual feelings, you can easily come to another decision. Well, if the brain is programmed in a religious way, then you can stimulate the brain in certain brain areas and you can get very religious feelings. And this is an example of a boy who had, during epileptic activity in the brain, very spiritual, ecstatic experiences. He even had direct contact with Jesus. And it appeared to be due to a tumor in the temporal lobe that was stimulating the circuits that are important for religious feelings. And after removal of the tumor, he never had that direct contact with Jesus again. So then the question came up, what would happen if somebody is growing up in a non-religious environment and this brain area is stimulated? Well, this is an example of that. It's a boy who was very successful in setting up a company in China, a Dutch boy. And he suddenly experienced what he had experienced during his puberty when he was trying some drugs out, some pados, etc. So he could feel the same thing as during those days for a few minutes. And he liked to experience that. It was a nice memory, just experience it again for a few minutes until he got an epileptic attack. And then an MRI was made and he sent those pictures to me by telephone, and you can see the tumor here. This is the tumor in the temporal lobe of this boy, who was inducing the same circuits, but in somebody who was not religious in his education, and he got this type of experiences instead. So it depends what you put into the brain during early development, what you get out during stimulation, for instance brain tumor. Well, to change gears, I now want to go from